Okay, so now we are live. Let us start with the class. So today we will be discussing flowcharts, and flowcharts are very powerful tool. The idea is that whenever we solve any problem, like before coding, first we have to plan it, what to code, what to write. It is not like, okay, a problem statement is given and straight away we write coding, we start to code. No. Whatever problem statement is given, we follow a step-by-step procedure wherein first we analyze the problem. Like, okay, what is the problem? What are the inputs involved? What are the outputs which I have to generate? And what are the restrictions? Any constraints are there? All that I have to analyze. And based on that, first I develop a process to solve that problem. And therein comes the role of the flowchart. And once the flowchart is approved, then we code it, we program the flowchart, and we get the result. So that is the idea. So the idea is that if I talk about flowchart, it is a tool. It is a tool which is developed and used in the computer industry, IT industry. It's a tool developed in the IT industry and very popular tool. Because when we solve big problems, like let us suppose as an IT company, if we want to develop a banking application, so just imagine the complexity involved. Like banking application has so many complexity. Or let us suppose we are planning to run run our own startup company. So we are planning to make our own e-commerce platform, for example. So that e-commerce platform which we will be making, that will be having so many complexities. So the idea is that first, whatever solution we have to develop, whatever product we have to develop, we break it into modules. We break it into modules. And from the modules, like individual modules, we first identify what needs to be achieved. And accordingly, we make the flow chart. So what is the main purpose of the flow chart? Using flow chart, we can show the step-by-step steps involved in a procedure. So flow chart represents steps involved in a process. Represents steps involved in a process. So flow chart, it visualizes the results of decisions. Like if we take this decision, what will happen? Like we are able to visualize the decisions, visualize the results of our decisions, visualize the results of decisions. With this tool, the flow chart, we are able to visualize the flow of execution of process. We can visualize the flow of execution of process. The flow of execution of process. Like in which direction the flow of execution of process. It's a very powerful tool, flow chart. And we can visualize iterations also. Iterations means loops. So using flowchart, we can visualize the results of decisions, that is if else and conditional statements. I can say that the bracket I will write it conditional statements. We know that in every programming language, there are so many conditional statements available. If else, if, then we have break, continue, switch. So these are like conditional statements. Iterations, you know that for loop, while loop. So we can visualize the iterations, and we can also visualize the function calls. Function calls. Now let us look at some symbols which we will be using for the flow chart. Some special symbols. Like see, whenever we draw the flow chart, we make use of some special symbols. That is what we are discussing. So I will draw it. So this symbol, it represents the process. Then we have a this symbol, which represents the data or the input output. Like whatever input we take, input data, and whatever output we generate. Then we have this symbol. It represents a decision. Then we have a small circle that represents the connector. Now we will look at some example to get more clarity how to use it. Then we have predefined process, like the shape I will draw. I have to draw it manually. the shape I am drawing, this shape represents the predefined process. So now we are basically understanding the nomenclature of flowchart, like the symbols, and this is the language of flowchart. Whenever we will be drawing the flowchart, these are the elements we will be using, and hence we have to understand what all these represent. And this is the predefined process. Predefined process. Then we also have terminal, like, or terminator. I can bring it. Then we have flow lines, the arrows. We have arrows. That represents the flow. So these are the main components which is used in any flowchart. Now, what is the meaning of a process? Process means the operation, the logic, which we will be writing. That is a process. Now, this process can contain some, it can contain some mathematical formulas also, some computations it can contain, or some logic building will be done. Input, output, it is very clear to us. Whatever input we take, the data we store it in this rhombus kind of a figure. And whatever output we are getting, we represent that in this rhombus. Then we have this diamond, that is a decision, if else. If this, then this. If that, then that. Like, based on the condition, we have multiple options. So that is taken care by this symbol. Connector is used to basically connect two flowcharts. Sometimes the flowchart becomes so big, it occupies 3-4 pages. So to connect individual flowcharts, we can use this connector. Then predefined process. Now, what is the meaning of a predefined process? You are already aware of the concept of predefined functions, like a process or a logic which is predefined. We are making use of it whenever we want. Like the print function. In Python, there is a print function. In C, there is a printf function. So this printf function is an inbuilt function. So it's a predefined process. If I have to print anything on the console, I am making use of a predefined process. I don't need to write my own logic. So in flowchart, that predefined process is defined with this symbol. Then we have terminator. Terminator represents the end of the program, or end of the flowchart. And we have these arrows which represents the symbols. Okay, this is clear. Now let us look at some examples how to use it. Like we will do some examples, then you will get a very good clarity that how to make use of flowchart, and you will appreciate the importance of flowchart also. So I am drawing one interesting flowchart, and you have to tell me what it will be doing, that flowchart. Like we will discuss that. So every flow chart will have an entry and exit point. So this terminator which I have written, this also indicates the entry point and it also indicates the exit point. Like we start the flow chart from this symbol and we end the flow chart with this symbol. And I have something like this. So at the very starting of the process, I am leaving home. Then I am getting some data. And what is the data which I am getting? That is the time, check time. So time I store somewhere in the memory. Like I get the time. Because this rhombus, it always represents the data. And these elements will be connected with an arrow that I will connect in the last. Then based on the time, I will be making a decision. And we know that I will be taking a decision. And we know that for decision, we have this diamond. I'm checking whether the time is less than 7 a.m. If it is less than 7 a.m., I will do a certain kind of an action. I will perform a certain kind of an action. Otherwise, I will be performing certain other kind of action. I will be taking decision according to the time. Then the logic which I will be performing. If the time is before 7 a.m., I will take the bus. Otherwise, I will take the subway. Because if I am getting late, if the time is more than 7 a.m., then I have to rush. I will take the subway. If I have ample of time, the time is before 7 a.m., I can take the bus. And finally, like the termination, like the end of the process or the final objective of the process is to reach school or reach college. Now let us connect this with arrows. Here, I have to, if it is yes, then I have to perform a set of operation. If it is no, then I have to perform a different set of operation. So this is how a flow chart is implemented. Like it's a very basic flow chart, but yeah, it's good for the starting point. So now looking at this flow chart, it is very clear that first I am starting, like the start of the process is leaving home. Then I will get the data because this rhombus, it represents the data. And what data I'm getting? Time. So I will get the time, and based on the time which I got, I check. Diamond means decision making. And whenever I have to take a decision, I take a decision based on certain conditions. If it is raining outside, I will take the umbrella. If it is not raining, I will not take the umbrella. So based on certain conditions, we take the decisions. And here I will check the time. The time is less than 7 a.m. If it is yes, I will take the bus. And if it is no, then I will take the subway. I will reach my like objective is the reach college. Then I will reach the college. So this is how the flow chart is made. Now let us look at one more example, wherein we will be drawing a flow chart to check the perimeter of rectangle. Flow chart to check the perimeter of a rectangle. So we have to do this. We have to draw a flow chart to check the perimeter of rectangle. And before drawing the flow chart also, first we have to analyze the problem. So first let us do that. So first let us try to identify in every whenever you draw the flow chart, the first step is to identify the input output and what processing you have to do. So here, in order to get the perimeter of the rectangle, what inputs we need? First, we have to identify. So the input we need is the length and breadth of the rectangle, or length and width of the rectangle. So length, comma, width. Then we will be doing the processing. In processing, we will be basically here, the logic will be the formula to calculate the perimeter of the rectangle. And what is the formula to calculate the perimeter of the rectangle? 2 into the perimeter. Two into L plus B. Then we will get the output. Output will be the perimeter. Now it is very clear to us that now this simple flowchart very easily you can draw. If they ask you to calculate the area of a circle, perimeter of a circle, area of a square, area of a rectangle, any formula based flowchart if you have to draw, you can take it as the template. Because any formula based flowchart, the idea is simple: input parameters, the variables involved in the formulas, processing will be the formula itself, and the output will be the whatever result we got. That will be the output. Now, if we draw this, so definitely we know that we have to start from the starting point, entry point of the. So this is the entry point of the flowchart. This symbol. Symbol is the thing which you should be well aware of. You should be well aware of this using these symbols. So this symbol represents the starting point also and the end point also. And here we can write start. Always, always write start. It is showing that we are starting the program or starting the flowchart. Then we have to take the input. So for input, I know that data, this rhombus symbol I have to use. I will use it. And I will write input space the variables I will be using. So capital L, capital. So you can take capital variables. That's fine. Then what I here, no if else nothing, no condition. Straight away, once I got the input, I just have to do the processing. And for processing, I know the symbol is this rectangle. And here the processing is directly just applying the formula. What is the formula? Perimeter capital P is equal to 2 into L plus P. Then what I will do, whatever result I will get, I will output it. Whenever input output I talk about, I'm talking about this rhombus. I will print P, the perimeter which I want. That is the output. Then my task is done. So I will stop the flowchart. So let me make arrow. So here straight arrows just here to nothing else. So this is very clear to us. So this is the flow chart to calculate the perimeter of a rectangle, and similar like this flow chart can be used as a template to calculate to like, work with any formula based problem. Now one more example we will look at. Now see, basically in this we have been given some line by line instructions, and based on that line by line instructions we have to draw the flow chart. So prepare a flow chart for the following. So these are the line by line instructions given to us. First, we have to start. Then we have to get the sum. Then we have to apply this formula. Average is equal to sum by 6. Then we have to output the average, the same thing, the same template we can use. Output the average. And then stop. Now let me just copy this. The same symbols will be used, nothing special. And we just have to change the data within the flowchart. So we will start, then we have to get the sum. So I will input sum, SUM. Okay. Sum is a variable which will be holding the value of the sum. Then average I have to calculate. So let me take capital A as the average. What is average? The formula is sum by 6. So whatever sum I got, I will divide it by 6. Then output the average. I will print A. Then I will, that's it. So this is how the flowchart works. So here it's very easy, just that you have to be aware of the symbol, right? For input, you have to, yeah, yeah.
Sir, we need to take the elements also, right?
Elements
Like the summation of 2 numbers or 3 numbers. So the numbers should be taken as an input.
yeah, yeah.
So that step is not here in the flowchart.
Yeah. No, in the flowchart, they are telling us get the sum. So it is been like we can assume that that sum is already been done and stored it is stored in some number in the form of a number. So sum we have already done. We just have to get that sum and store it in a variable and calculate the average.
Oh, okay.
Yeah, and it is very important. Like see in engineering and like when you get into the industry also, whatever is said to us, we have to be stick to that. We cannot do anything on our own. Like here, whatever is said to us, it is said that just get the sum. Now you might think that get the sum means it might mean that add numbers, but no, get the sum means here in this context, sum is already been done. You just have to get the value of it. It is already been done and store it in a sum variable and use it to calculate the average. So the idea is that whenever we develop any system, whenever we develop any IT solution, any tech product, first we do the requirement analysis. In the requirement analysis, we sit with the client, we discuss with the client, what to do, like what is the thing which needs to be developed, what is the thing which needs to be developed, and what are your requirements, what is the problem you are facing, how we can help you. So requirement analysis is mostly it is in English, like it is normal formal language which we communicate in. Then we convert that requirement into bullet points like this, and Based on that, we first make the flow chart and then design algorithms, then implement that algorithms, and then we do the testing. And once the testing is done, we deploy the solution. Okay. Now we will discuss one more important topic related to flow chart. That is flow chart constructs. Flow chart constructs. So we have a sequential, the conditional, and loop iteration. So three types of constructs we have. Let us discuss one by one, all of them. So I will take this. So I will write it here, heading. So if I talk about the flow can be sequential. The flow can be conditional. Conditional involving decisions. The flow can be loop or iteration. Now we will discuss how to draw all these because loops are so important and these decisions so we have already seen how to draw that, but still once again we will look at it. Properly. Okay. So we have processes like all this. We know that this rectangle it contains some logic, some process. These logic they are bundled together sequential. So the idea is simple. The idea is that at any point the flow will be like this. It will reach any other. Similarly, for conditional, I will be making use of that diamond because for decision making, we have already seen we have to use this diamond. Based on the condition, we will be having two options. Either go with this or go with that. So based on the condition, two options. Either go with this or that. So here also the idea is pretty straightforward. Like, okay, from here we will be going to this condition. And let us suppose the condition is true. Then some set of actions will be performed. And if the condition is false, some other set of actions will be performed. And finally, I will reach to the next part of the flow chart. How the loop works, it is interesting to see the loop, and it's very important how to draw the loop in a flow chart. What is the concept behind that? So here the idea is simple, that see this diamond is condition, and we know that in the loop also every time we check the condition until the condition is true, loop will keep on running, and once the condition is false, we will come out of the loop. So the idea is that if I get into the loop, first thing is to check the condition. If the condition is true, I will perform some logic, which is the part of the loop, which is inside the loop. And then once again, after performing the logic, once again, I will check the condition. Once again, I will check the condition. And if it is true, once again, I will perform that logic and I will keep on doing it. And if it is false, then I will come outside the loop. If the condition is false, then I will come. So this is how the loop works. This loop is very important. Now, one more thing we will discuss, very important. Now, actually, we are building the basics. We are building the basics. Like C programming, C++, they also support switch statement. And switch is very popular. Now, let us see how to draw it, and we will also understand what the switch does, like how it works, switch statement. So I will be I have to make use of the start and stop. Or let me just okay, wait. In the switch, some expression will be there, or some value will be there, and we know that data we always store in this rectangle. So in the switch, I will be having some data, some value, and based on that, I will be comparing it. That will be the case. So this is the condition 1. Then we will be having condition 2, condition 3, and so on. Condition 3 and condition n. And there will be a default condition also. The switch, there is always a default condition. Like what is default condition? If all the above conditions are false, then default condition we will get into the default condition, and it will always be executed. Default condition always gets executed. So based on this condition, if it is true, then I will perform some action, so some logic will be performed. Otherwise, I will check the next condition. If it is true, some logic will be performed. Otherwise, I will once again check the next condition. I will keep on doing this. So now let me draw the flow for this switch. So here also, like from any part of the program, like somehow I got inside this switch. And here I have the switch statement. So switch keyword is used. With some data. Or to be more precise, I will call it conditional expression. Conditional expression. Now what I will be doing is, I will be going to this. And diamond is a decision. If the condition, here a condition will be there. I will write it. It is the case one or case condition. It will be the case condition two. It will be case condition three. It will be default. Now see, now I know that condition can be true or false. If condition is true, then only this logic will be performed. Otherwise, if the condition is false, I will go to the next condition. I will check the next condition. If the condition is true, I will perform the logic. Otherwise, if the condition is false, I will go to the next condition. If the next condition is true, I will perform this logic. Otherwise, I will go to the default condition. And once I got into the default condition, whatever logic is there, whatever process is there in the default condition is by default true. No scope of becoming false. So whatever logic is there, it has to get executed. It has to get executed. And in the logic, whatever logic I have, that I will perform. And I will break. Break means I will come out of the switch. Logic I will perform and then break. Logic I will perform, then break. Here also logic I will perform, then I will break. And here no need for break. In the default, since it's the last, here I can just write the logic. Now, what will happen? Like the idea is this: after performing all the logic and break, I will come out of the program. Not the program. I will come out of the switch construct. So this is how the switch statement. Okay. So these flowchart constructs are important. The syntax. Now let us look at one more example. One example we will complete based on whatever we have studied. Let us make one flow chart. Let us make one flow chart. So what now we will be doing? We will be determining whether the number is even or odd. Determine and output whether number n capital L is even or odd. Now first I will write the steps for understanding very fast. Then diagram. Ultimately, flow chart is the thing we are interested in. So these steps I am writing just for understanding purpose. So for what will be the first step? First step will be to get the input, get the data, get the number. So read number. Once we have the number, we can straight away apply the logic. Step 2. Remainder is equal to n modulo 2. Step 3 will be the condition. We will check whether the remainder is 0 or not. If remainder is equal to 0, then n is even, else n is odd. Step 4, print the output. Step 4 is to print out. So this is the step. It is always very good that in the exam, if you have been asked to draw the flow chart, and if you see that that question is carrying good weightage in terms of marks, it is always good to write steps also. And then straight away you can draw the flow chart. Like I am just copying it. Like symbols, same symbols we have to use. Just copy this. We will change it accordingly. So we will be starting flowchart. First is the number. So input n. Then I have to perform a operation, a logic. I have to perform a logic. So this thing I will take. Logic I perform in a rectangle. And what logic I have to perform? I have to calculate the remainder. R is equal to n modulo 2. Actually, in some of the programs, this modulo is done with a, in some of the programming languages, this modulo is not the percentage but some other sign. So we can use the we can write modulo because that because the idea is that flowchart is independent of the programming language. Whatever flowchart I am making, it should be generic. Any programming language should be able to implement this flowchart. Okay. Once I get the remainder, then what I have to do, I have to check condition, decision making, and R equal to 0 question. I am checking whether R is equal to 0 or not. If yes, then I will say answer, or straight away I can print, or let us be precise. I am defining a variable called answer, and that variable will hold even. Otherwise, answer will be odd. And before terminating, I have to print the output. So let us do that. Let us do that. So let me. I know that for printing also, for input output, I have to use the rhombus. output. What I have to output? I have to output the answer. The content of the answer variable. Then I will be ending the program. So this is a very interesting flow chart. To determine whether the number is even or odd. And now we should be very happy that we are upskilling, we are developing a skill to analyze flow charts. Now, whatever flow chart you will see, because any project you take, the project report, it contains flow chart. So now you can analyze the flow chart and can understand what is happening in that project or in that software, that the code, what is happening. So today we will keep it in here.